dysfunctional that. I'm in the process of getting these panels back into service. This one has been out of service and was stored in a place where things were leaking, and unfortunately it fell on it and it knocked this back panel off. And I have not found it. I will eventually. You have 3 leads that are coming in off of the panel. This one right here comes in, it passes through this diode to this point. This one comes in, these 2 diodes are connected, come to here, and then this is your positive. This is your negative, and it goes back in here somewhere and attaches into the cables. I'm not exactly sure where everything is coming and attaching. You can see that there's nothing visible as far as wires are up here in this area. So they've got to be coming just straight off of these leads, front and back, this way. Now, this lead had been knocked out and had been bent pretty bad. I straightened it up with a pair of atraumatic flat needle nose, well, they're not really needle nose, stub nose. And then using needle nose, I shoved this back in. Positive, negative. I had 18.9 volts open voltage here. So I know the panel is now working. It's now time to get this back into service. So let's discuss a couple of other things before we get any further. We're inside the shop, and on this panel you can see that the positive from the panel goes here, the negative there. On the battery, your positive is here, your negative is here, and then the load that's going to be carried is going to be positive here, negative there. I don't remember what I paid for this. I got this off of Amazon. This is the 3rd one I've bought. The other 2 were bought while I was in school, and I have no clue where they are. Stuff's been packed away, and it just isn't worth looking for. The panel that we just discussed is going to be bringing a load in here, and it's going to be attached to the battery. Once it is attached to the battery, this panel is going to be dragged down to the voltage of the battery. MPPT does not allow that to happen. It takes the power off of the panel and it modifies it to get the maximum amount of power available to put into the battery. So now this is 18 volts open, but once this is hooked up to the battery, it's going to drag that panel down to about 13-14 volts as it pushes power into the battery. So that's something you need to be aware of. Now let's talk about batteries. This is a small lead-acid rechargeable battery. It's 6 volts, 4.5 amp hours at 20 hours. And there's going to be something like a C8, a C4, a C6. This would be a C20. We'll get into that in another video. If you look at the top, you got your positive and your negative. The positive's got the big clear red on it to let you know that's positive. Positive from the charge controller to the positive, negative to a positive on another battery to a negative back to the charge controller, and you have a 12 volt battery. So this, you can put these in series or in parallel. If these were in parallel, you'd have a 6 volt with 8 amp hours, but if you put it in series, you have a 12 volt 4.5 amp hour. You don't get any benefit, you don't get additional amp hours out of it. This hooked up to that panel would recharge very quickly because it's pushing 100 watts into that panel, or about 5 amps. Batteries have what's called internal resistance. When you think of voltage, it's pressure. It's the pressure to push the electrons. So if you have 12 volts, you have think of PSI. You have 12 PSI pushing the electrons. So that pressure overcomes the internal resistance, and this thing now becomes a chemical generator of electricity. When the voltage begins to get low, it has less pressure to push the electrons, and the battery will start to get hot. So you always want to keep these things in tip-top shape, and there's what's called a depth of discharge. So it's 100% right now, and as you use the battery without a recharge on it, the battery slowly sinks down. When it reaches a certain state, it's going to start damaging the battery due to the internal resistance in here trying to push those electrons on across. So you need to be aware that you don't want to discharge too much. There are some batteries that there are claims that they can be discharged all the way down to zero many thousands of times. I'm not going to get into who makes them or anything else. Do your own research on that. And they'll come back up and they won't be damaged. I can't speak to their efficiency. All I can do is tell you that there are people that are reporting these things exist. But you have a depth of discharge, and on some of these you don't want to go down as low as 20%, or you don't want to drop below 20%. So you've used up 80% of the battery and you're down to 20%. That's your battery left. When I was in school, we tried to never drop below 50% ever, regardless of the battery. I mean, how deep it could go. We tried to never drop below 50%. Now, the school that I was in was based on industry standard, not residential. Industry is a little different from housing. On a housing, you want 3 days worth of battery, and in industry, it's better to have a whole lot more than just 3 days. Now, think of it like this. You have a weather station up on top of a mountain somewhere, and this thing is reporting information back. If you only have 3 days, you could have a storm that lasts a week up on top of that mountain, and you would not be getting your telemetry from that weather station. So in that case, you want a lot more battery capacity to last a whole lot longer. So that's something to think about. The average Joe in a city is not going to be in the same kind of position as a rural that somebody on a remote mountaintop might be. So you could probably get by with 3 days. Now where I live, if the power goes off, it's going to be off a minimum of 2 to 3 days minimum. That's if everything is good. Normally it is off for somewhere between 5 and 10 days. The longest that I remember it being off was 10 days, but 5 to 10 is the average whenever there's a storm and the power goes off. So that's something else to think about. How much battery backup do you need? And these batteries are expensive. Don't kid yourself. So that's another issue to take in. Let's talk about battery efficiency for a moment. We're going to be putting 100 watts of power into this through the charge controller. If it takes 150 watts of power in order to bring this up, it doesn't have a real high efficiency because it took a lot more watts to fill this up than what it should have. If, on the other, it only took 90 watts to fill this up, then this would be a very efficient charging system. So that's another aspect of batteries that you need to take into consideration. Let's deal with one thing and then we'll move on to one more subject. You have these batteries that are really efficient at recharging, and they have deep discharge on them. You're in a city somewhere and you get snowed in a blizzard. So for 3 days you're pretty much without power, and your battery is really getting low down here towards the bottom of the battery. 100%, 0, and you're getting down here real low. Well, if the sun comes out and you have a very efficient battery as far as charging goes, you might be able to bring them all the way back up to 100% in, say, 6 hours of sunlight if you were to get that. Or you might be able to bring it up a higher percentage just on some less than quality light. Bright sunlight, dim sunlight, whatever the ambient lighting outside, that's called insolation, and it means the second by second intensity of the sun which is striking the panels and producing the energy inside those panels. The word is insolation.